Hi guys, and welcome to another video. As promised the other day, I'm going to deal with Lambda 8300 again, trying to get better picture. um, uh, I was thinking maybe the power supply is not sufficient. It's only capable of delivering 600 milliamps, and it's the US type, so it requires 115, 120 volts AC, but might not be the case. I read about the composite output that it might be working fine over CRTs, and so the problem appears only on TFT LCD screens. But either way, I was thinking I'm going to use an RCA jack, classic solution, put it somewhere around here, somewhere there, so I can get a composite-like signal from the TV tuner and forget about the monitor one. Whenever I have the chance, I'll test it over some CRT, but so far I haven't tried it. And so whatever comes in my mind to make this little fellow to work better. Um, the keys are working, the logic is working, everything is working since the previous time um, we have made this other video. And it was just then when I came up with this idea. If you have watched the video, I tested the signal from the TV modulator so we can have composite-like output somehow, and I skipped the drilling part, and so I'm gonna pick this spot to put my RCA right there. It's gonna be looking like this, and we hopefully can get a better picture from the first leg of the TV modulator coming out. And it's gonna be working fine over modern TFT LCD TVs and screens and stuff. Another thing I wanted to mention and to point out here is the terrible connection to the keyboard and from the motherboard and vice versa, which is not giving us a lot of space to work with the computer, and it's very weak and terrible quality. So maybe it's just an idea. We can replace this ribbon with proper cables, but first things first. So I put the cable right there, coming from the first leg, the closest to the case, and the ground connection on the top of the TV modulator. And I can already see that it's getting weak as it was moving the connector to the keyboard. So that's going to be probably step number 2. The joints, the soldering is bad. It's probably going to give us some trouble. The picture looks good with this new RCA. The signal is looking good, and so I'm gonna be replacing the wire with a shorter one. Now, as I was closing the case, I found out the LED indicator didn't come up, and that was the first hit. It was somewhere cut, and I had to resolder or try to resolder everything. Again, those connections are terrible underneath the keyboard and to the motherboard, but of course the RCI is in place, and now the indicator, the LED, is up again, and yeah, we're getting far better picture. So let me test the keys to check if any other joint might be damaged or anything. First numerical reset, enter. I guess it's okay. So the LED is coming along with the rest of the cables. The power for the LED is coming along with the rest of the cables through these connectors. So another thing that needs to be fixed is this ribbon, sort of ribbon cable, as soon as possible, I guess. After resoldering the joints, I think the keyboard works fine. Now I try to put up again little silly program to check that everything is okay, and apparently looks okay, and it does. The other thing I was thinking about this machine is that it has it is a clone to the ZX81, but the ROM is of course twisted or modified, which means that the memory mapping is or should be totally different. Now this machine is based around the Toshiba 2016, which is static 2 kilobytes RAM chip, and they skipped the 2014s. They should have been in place right there in the first place, and so it has 2 kilobytes of RAM instead of just one, like the ZX81. Not to mention the differences within the ULA chip again. And so one way to pick into the memory and try to see similarities and compatibility issues, probably it's the best way is to write a program and check the memory mapping or allocation, if you will. And here is something that I pulled from the internet. It's pure ZX81 basic, and hopefully this will return the memory size of the machine. And let's run it. It will take a couple of seconds to go through, and then it will come up hopefully with a result, which is 48K. Well, not exactly what I was thinking and anticipated. So it's clear that it's not fully compatible with ZX81. I think the memory interpreter, the basic interpreter works fine, but the memory mapping is somehow different. Let me try this again. And so yeah, this is not right. Of course, it's just 2 kilobytes of RAM in there, and I wish it could be 48K, but this routine doesn't work, and I really think I should get back to this. So we have a cheap but beautiful machine, if you ask me. We have the composite out right there. I'm pleased with the resolution and everything, at least on the TFT LCD screen. The external bus, everything is there, the joystick port, and I was thinking maybe I can put a nano switch right there in the future, another video probably. We have the external bus compatible with ZX81 for the most part. Maybe I should even try to put a memory upgrade of 16K at some point. And here I have a ribbon cable, actually a couple of those, the colored ones and the gray one, and maybe I was thinking I should do something with the keyboard, although it wasn't planned, but this gives me trouble, and can give you trouble whenever you want to do something and want to open the machine and everything. It's very unreliable. So I think let's do it over this video. So I will open it up again and get rid of the old ribbon cable. This is a shame. Make clear. I will try to make clear connections, clean, and I'll put the new cable into place. Those are 16 points to be soldered on both sides. So I was thinking maybe I could use this gray ribbon cable, the one that I have found in my spares, this one, because it has more cables, but it's gonna be kind of confusing to check which one is which, so I'll stick to the smaller one, and I'm gonna be using a couple of those just because it's easier to the eye to it will help me to identify which is which, and these are 7, so I need 2 of those pieces, and 14 and 2 more. And so I tried to clean the best way I could the contacts. The focus is right on both sides. It's kind of tricky because particles from old solder can stay in between and give you a short, but I think we're good now, we're good to go, so I'm going to start preparing, and I think it's going to be underside up instead of going on the upper part of the PCB. The best way to clean it thoroughly is this guy, the pump, the soldering pump, and that's your best buddy during this operation. And yeah, I was saying, yeah, I'm gonna do this, gonna need 2 of those, and I'm going to those 2, and I think they are long enough. And of course, in order to go underside, I have to remove the PCB from the case, the bottom case, and it looks kind of dirty at some point, but I'm gonna use the classic isopropyl alcohol and clean the joints, and the joystick port looks pretty dirty, and the whole thing, the external bus connectors, looks like they have never connected anything, so clean. So I'll give it a good clean and start as I said, putting the cables, connecting the cables underside up. Maybe I could replace the speaker, I could replace the heatsink, and probably the voltage regulator. The voltage regulator is a good idea because we can place the modern ones which produce no heat and make it more reliable over time. But this one, this machine doesn't produce a lot of heat while in operation. So I'll stick to the plan, and maybe this is another project. For now, I'm going to tin the cables with a soldering iron, so they are going to be ready to go on the side and all the way up to the other side of the PCB and go across and reach the keyboard. I think the length is right and everything is right, so I'll prepare both cables, both ribbons, skipping now the boring soldering part. I have prepared the bottom side, just a couple of grays on the sides, 1, 2, left and right, in order to make 16 in total. And you have to be cautious because some points have contacts on the bottom side, but also on this top side of the PCB. So you need, I guess, to double check and triple check continuity and contacts. So you're gonna be using a multimeter, as I did, send to continuity or the buzzer sound, and check every contact separately. The thing is, no cable, no contact should be in contact with one another. So this means that let me set this to continuity, and the buzzing sound, nothing should beep. That's the whole point. Nothing should beep. All 16 cables are connected to the keyboard separately. So yeah, let's move on. And I think I'm gonna be putting some glue under the cables to hold them tight right there. That's the underside, the bottom side of the PCB. Glue is always a smart idea, like they used to do in the old days. Not because it will hold those together, although the joints are strong enough, but also because it's non-conductive and it wouldn't affect the circuit at any point. So let's put the PCB back into place in the bottom case, and I've put some cellophane tape to hold the first one and the last one together, and soldered the other side of the ribbon to the keyboard across. And I think it's pretty lengthy. That's the first draft. I've put some cellophane tape as well. It should be looking like Commodore 64 by the end of it. So I'll be going on with the second part of the keyboard, the ribbon, the second ribbon, and see what happens. It looks good. You have plenty of space now to work. Again, always checking each and every connection, each and every cable with multimeter set to continuity and the buzzer. And yeah, let's hope that we have a better keyboard by the end of the day. And the length, as I said, looks good. I think it's sufficient so you can open the machine, do stuff without the fear that it's gonna be some joint or some connection will be broken after all. And it looks pretty robust, and I think now we can see here how it looks, the final setup, the final repair or fix. One thing I wanted to point out is don't forget to check the screws holding the keyboard together. Those might be loose after all these years, and moreover, because this whole computer might be interesting and beautiful, but it's cheap, and the keyboard makes no difference. So again, check the screws and make sure there is no dust, rust or dirt underneath, so you won't have any problems with typing your programs. So I think we're good. That's one of the final inspections. Overall, again, now that it has finished, you can see there is more tape to hold the ribbons steadily there. Looks more like a Commodore 64 now. I think yeah, the length is fine, and one other piece of cellophane tape should be there as well. But yeah, again, the length is fine, I guess, so you can open it, you can do stuff pretty easily. I have replaced also shortened the wire for the composite mode we did before. The screws, every screw is holding the PCB into place, so I guess we're good for one of my favorite parts, of course, which is testing. And I checked also, needless to say, the contact points with the multimeter, so it looks good, should be good. I'm going to fire it up in a while and see if everything works fine. And that was an interesting project, and I have this idea that I'm going to revisit this machine. I think I'm going to revisit this motherboard for something more in the future. I have this certain feeling. It's so playable, you can do things. There are things available, but there are also some things that are missing, essential things. So powered up, we got the power on, the LED came on, the ready sign and the cursor on the screen looks good. This is so promising. And now let's type a few characters. We'll go line by line, 1 to 9, 0, reset, and then next line all the way, and then again reset, and then move to the next line, and then again reset, and I think we're good, guys. I think we're good. I'm very happy, very pleased with this. It was quite an improvement on this particularly interesting and beautiful machine, although cheap, but yeah, Chinese and a clone of ZX81 and all that, but still a wonderful machine. I know many people in Southern Europe have started using this machine back in the day, in the mid 80s. So I think it is it feels good to have it in perfect order, working order, and with quite some improvements. All we can get to restore all these machines from the past that we grew up with. We do everything that we can to restore operation, to repair, fix, and improve, in many cases, the operation of these rare and old machines from the past. So thanks for watching. I'll be catching you soon with another video, probably over this one or another system to be checked, fixed. Thank you for watching. Consider subscribing, and yeah, give us a thumbs up if you like this stuff. Consider subscribing to our channel. We'll be more than glad to hear from you, see comments, read comments, questions, whatever you have in mind, and yeah, I'll be catching you soon. I will be closing this session, successfully writing another silly line of code, and that will be all for the day, I guess. Again, if you have any other ideas about this particular machine, just comment and get in touch with us. So thanks again. Bye.